Hey Dev Team, welcome back to Flutter with Drag. Just taking a short break from our series that we're currently working on, just to do this one-off video, which is a bit different and for a bit of fun. This isn't a series, this is going to be a standalone video. And what we're going to do is attempt to recreate a basic version of the Minesweeper game, the classic Minesweeper game. It used to ship with Windows. I say basic, I'm not going to spend much time on the design at all. We're just going to really concentrate on the functionality and the coding. So that said, I have a brand new Flutter app here installed. I haven't touched it yet, and we're going to work from here. I haven't installed any dependencies yet, but I'm going to install just one, and that one is going to be Flutter_Block. So we'll get that installed and get cracking. Let's start by deleting the entire of the My App and rebuild it. So stateless widget, My App. That's going to return a material app, and in it, it's going to have, I'm going to do a debug show checked banner to false to get rid of the little banner, and we'll have a home, and we'll have another widget called app home. And to be honest, I think I'm just going to keep it all within one widget, so I think that will be it. So let's create that widget, app home, and that is going to have a scaffold, and inside that scaffold we'll have a body, and we'll put a safe area in just to make sure that we're all within bounds, and we'll have a child to that which will be text hello world. If we save that, it should put the consts and whatnot in for us, and we have our app ready to go. Okay, so I installed Flutter Block because I am going to be using a block pattern for this. So on my lib folder, I'm going to right click and create a new block. And I'm going to call this block game board, like so. Now, if you haven't got that, when you right click, you'll need to install a Visual Studio Code extension, which is this. It's Block by Felix Angelov. And that gives us the ability to quickly create blocks. If you don't want to install that extension, then you'll just need to create the code by hand. It's not too difficult, and we'll look at each file one by one. So let's start with our game board state. Okay, so if you haven't got that, you'll just need to copy this down and go from there. So we're going to have two states. We're just going to have the initial state when we're generating our board, and we're going to have a game board playing state, which is going to extend the game board state. That's going to have a few things in it that we're going to need, and we'll come back and put those in as we need it. In our event board, we're going to need a couple of events. The first event is going to be when we require a new board to be generated. So we could call it load board or generate board. I'm going to go with load board, and that's going to extend a game board event. And that's going to take no properties in it. That's just going to be something that we can call, and that will be the instruction to our block to generate our board. And then finally, in our block, we're going to have, in fact, just delete that. That's the code you need to start it off if you haven't generated it. And then we're going to say on load board, we want to call the method load board. That doesn't exist yet, so I'm going to control dot that create method, and there is our method to load the board. Excellent. So that's our setup mostly done. We now need to provide this block to our game board, and I'm going to do that on the scaffold. So outside of the scaffold here, I'm going to control dot and wrap with block provider, and the block we're going to provide is going to be game board dot block, and we'll need to import that. We'll also need to import Flutter Block for that to work, and then it's complaining that it can't be a const, so we'll just switch those around. Okay, so the game board block is going to be set up, and immediately that it's set up, we want it to generate our first board. So immediately we're going to add our load board event, and that will instruct our block to create itself and then call the event load board. Once we've done that, then within our safe area, we're going to see whether the state is loaded and do something about it. So here we're going to wrap that text that we've got into a block builder. The block is the game board block, and now it's complaining about this const which it's put in, but we can get rid of that. And we're there. So within the builder, we're going to say if the state is game board playing, i.e. if our board is loaded and we're playing, we're going to do something. For now, we're going to return the text hello world. Else, we're going to return a circular progress indicator while the game loads. So immediately you can see on our app we've now got a circular progress indicator because our board doesn't do anything yet and we never change it to the game board playing state. That's pretty much the setup done and the boilerplating done. Now we need to create a board. Well, what's a board going to be made up of? Well, a board is made up in Minesweeper of various cells, and those cells have various bits of information. So what we need to do, I think, is create a model for that. So I'm going to create a new folder called models. There's probably only going to be one model, and I'm going to create a new file in there which I'm going to call game_cell.dart. So what's a game cell going to look like? Well, it's going to be a class called game cell, and it's going to have some information. First of all, I want to know, is it a bomb? That's important. Secondly, we're also going to want to know the position of this cell on the board, and this will make sense in a moment. So I want to store the X and Y position. So I'm going to create a new class for that called grid position. And that's going to have a final int, which is the X position, and a final int, which is going to be the Y position. And we will create a constructor for that, this X, this Y, like so. And I'm also going to override the toString method so we can easily see what has been set for the grid position. So to do that, we just override the toString, and I'm going to return a string with the X and the Y value there. So in our game cell, we can now say we'll have a final grid position, which we'll call pos. Let's create a constructor for that, const game cell. It's going to take in a isBomb and position. Now, neither of these can be required, or don't need them to be required, but I'm going to set it as a default to no, it's not a bomb, and as default the position to well, actually I'm going to require it. Yeah, yeah. There can't be a default position because they've all got to be different. So we're going to say that that is required. Having got the basics there, we now need to generate that board. So let's come back to our block, and just outside of the class I'm going to store a couple of constants. The first one is the size of the board, and although in Minesweeper you can set custom boards of different sizes, I'm going to say here for our version that they're always square. So whatever the size we choose on one axis, it's going to be the same on the other axis. Just makes life a little bit easier for us. So grid size, and let's capitalize that. I'm going to set that initially to 9, which is the default size of the basic game within Minesweeper. So let's come to our load board. And so to work out the number of cells we need, I'm going to set a final int number of cells to equal the grid size multiplied by itself. A const rather than a final. So number of cells, let's make that plural. So 9 by 9. And then we're going to create a board. And the board is going to be a list of game cells. And I'm going to call it board. And I'm going to use the list.generate function to create that. The length is going to be the number of cells. And so then we get an index, and for each of those we're going to return a game cell, like so. And we need to put in a position. So how do we work out the position from the required, from the index? So the index is going to go from 0 upwards. Well, what we need to do is a little bit of maths. So let's have a look at this. I'm going to put this onto another line here and here. And so the position is going to be a grid position, and that's going to take in an x and a y. So the x is going to be the index with the modulus of the grid size. And the y is going to be index divide by the grid size. We're going to floor that, which means reduce it down, get rid of the decimal point effectively, and then again modulus to the grid size. So what does this do? Well, it basically tells us the number of times something can happen and sort of gets rid of the remainder. So effectively what we're saying is take the index number and divide it by the grid size. So if we take the number 12 and we divide it by 9, we get 1 with a remainder. And so this will just give us 1. So if we take number 5 and divide it by 9, we will get 0 with a remainder. And so that'll be 0. And you'll see how that translates in a second. Okay, so we've got that. We now need to save our board. So let's come back to our game board state, and that's going to be the first property we're going to put into our game board state. It's going to be a list of game cells called board. We'll need a constructor for that, so game board playing this board, and we're going to require that. Okay, so let's come back to our block, and after we've generated the list, we're going to emit the game board playing state and set the board to the board. Right, save that. I'm going to do a restart because we've messed around with the block, and that should have loaded in. So there now should be a board created for us, but we can't see it. So let's come back now and change around this text hello world and actually produce the board. So instead of hello world, what we're going to do is return a grid view count. Okay, and the count is going to be 9 for now. The children of that then are all going to be the state board. So we're going to take all the boards that are in the state, all the cells, sorry, which are as part of the board, and we're going to map that. Okay, that's going to map to a cell. And we're going to return a container. And then we're going to convert that to a list. Okay, so for each of the cells within our board, we're going to just return a container. And we're going to set the child aspect ratio, so all these containers are children, to 1, which means they're going to be a square. And so we can see it, let's put in the container a color's red, and save that. And so we now have a big block of red. So let's put a bit of spacing in there. Let's put in cross axis spacing of 3 and main axis spacing of 3. And there you are. You can now see our grid that we've got for each of our cells. Okay, that's good. What we need to do now is set some of these cells to be bombs. So in fact, I'm going to change the color here to grey. And let's pick a shade. Let's go with, I don't know, 500. Yeah, that'll do. And we're going to generate some bombs, and for testing we'll set those bombs to be red. So how do we generate the bombs? Well, let's come back to our game board block, and after we've created our board, but before we've admitted it, we're going to go through our board and generate some bombs. Okay, so how do we do this? Well, we need to know how many bombs we're going to want first of all. So let's put up here next to our grid size number of bombs, and we'll set that to be 10. And then after we've generated the list, we will have a little counter here called bomb count, and we'll set that to 0. We will need a rand, so we'll call the random there, and we'll need to import that from Dart Math. And then we will say while bomb count is less than the number of bombs. So we're going to do this for 10 times essentially, but we might do it more than 10 times. But you'll see what I mean there in a second. We're going to say int index equals random next index. Maximum number is going to be the board length. Okay, so it's going to pick a random number between 0 and the board length, so all the cells. Then we're going to say if the board cell at that index is a bomb, well, in fact we're going to do the reverse of that. We're going to say if it's not a bomb, putting that exclamation mark there, then the board at that index is going to equal the board at that index copy with, and we need to copy it. We haven't created that function yet, so we're going to do that in a second. Copy with is bomb true. Okay, so let's just go back and create this copy with. So this is in our game cell, and I'm just going to generate a copy with. Again, that's an extension, but you can just type that in if you haven't got it. Okay, with that we've now copied it. So the reason why we've done this in a while loop is it's possible that the random number will pick something that's already a bomb, in which case it can't be a bomb twice. So as long as the index it hasn't picked, if it isn't a bomb already, then it's going to set it to the bomb, and then we will up our bomb count by 1 to say we found a bomb. And once we've finally got 10 bombs, it's going to be done. Okay, and then we're going to omit the board. So let's save that and come back to our main, and here for our colors what we'll do is we'll say if the cell is a bomb, then we'll have colors dot red, otherwise colors dot grey. Now we'll have to change that later on because obviously we don't want people knowing where the bomb is, but that's for testing. So let's restart that now, and that should generate a bomb, and we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bombs. Perfect. So that's the random location of the bombs. The other thing I'm going to do just for a moment is just make sure our positioning is working, because we haven't tested that yet. So I'm going to set the child to be text, and the text is going to be the cell position toString, and that should load it in. So yeah, we can see the first one is X. So as we go along the board, the X increments, and as we come down the board, the Y increments. So we can see that our XY coordinates are working perfectly. Let's just make that a tiny bit neater just by wrapping that in a center so that they're centered in the board. So what happens when we come to it? Well, there's a couple of things that we can do. When we click on one of these, if it's a bomb, the game's over. That's it. All the bombs explode and the game is over. So that's one state that we need to deal with. Secondly, if we click on one that is adjacent to a bomb, so all of these here are adjacent to the bomb, what it does is it shows us the number of bombs that are adjacent to that cell. So if this 2,5 cell was clicked, it would show us the number 2 because we've got these 2 bombs next to it. Whereas if this 3,7 was clicked, that would show us the number 1 because it's only 1 bomb next to it. And then the third way it works is if you click on one that has no bomb near it, it clears itself and its neighbours, and it keeps going out clearing until it gets to the edge of a bomb or one of the ones that has a bomb neighbouring it. So we need to code all that, and all of that sort of relies on us knowing which neighbours are next to each cell. And because we have to do that a few times, i.e. when clearing it and stuff like that, it makes more sense to calculate the neighbours for each of the cells immediately when we generate them, and so that each cell always knows what its neighbours are. So to do that, we're going to come back to our game cell, and we're going to store a new bit of information, and we're going to store the list of the neighbours. Now this is going to be a list of integers because it's going to be the index of the neighbours in the board. Okay. So this neighbours by default is going to equal an empty list. So when the cell is first created, it's not going to know what its neighbours are. And we'll just update the copy with to include the neighbours. Okay, let's come back to our board block. So this section of code generates the bomb, picks the random bombs. So I'm actually going to hoof that out to its own method. So I'm going to select it, I'm going to hit Control dot and extract method, and I'm going to call that generate bombs, and that's sent out to its own little function. We know that's working, we can forget about that now. Okay, so calculating neighbours, how are we going to do that? Well, what we need to do is we need to iterate through the entire grid. Now, at the moment, we're not actually storing the index. So a game cell doesn't really know where it's at, but it doesn't need to in terms of the index. And let me explain what I mean by index. Even though we've got a grid position here of 0, 0, its index is naught. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is index 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Because these aren't stored as a grid. These are all stored, as you can see here, as a list of game cells. So although the cell knows its grid coordinate, the board itself doesn't. The board deals with indexes. Okay, so given that, we need to run a for loop, and we need to set for I equal to 0, because the first item in the list is at position 0, index 0, while I is less than grid size multiplied by grid size, I++. Okay, so that is the same as the length of our board, the number of our cells. And what we're doing now is we're saying for each of that cell, let's do something. So what do we want to do? Well, let's get that cell. So the final cell equals the board at that index. Okay, so the cell that we're working on is on the board at that index. And at the moment, we're going to have a list of integers called neighbors, which is going to equal an empty list. Then we need to go through our cells. Let's do something a little bit outside the box here just for a second, just so we can see the numbers. What we're going to eventually do is store the number of bombs. So I'm going to come back to our game cell and I'm going to put in here final int number of close bombs. Okay. And let's add that to our constructor. This number of close bombs, and we're going to default that to naught. However, let's update our copy with as well. However, what I'm going to do is when we generate the list, I'm going to set the number of close bombs equal to the index. Okay, and then come back to our main.dart, and instead of doing the position, I'm going to output the number of close bombs. Let's do a refresh of our app, and now we're seeing the index. I only did that to make it easier to explain what we're doing here. So let's take number 20. Its close neighbours are 10, 19, 28, 11, 29, 12, 21 and 30. And so we need to store all those numbers in the cell's 20s close neighbour or neighbours list. However, some of the cells don't have that many neighbours. This cell, for example, only has 9, 1 and 10 as neighbours. Okay, it hasn't got anyone else on the outside. So we need to do that calculation. So we're going to say in our for loop here, we're going to have another loop. Int x equals cell position, the current cell position, -1, while x is less than or equal to the cell position x plus 1, x plus plus, increment by 1. Let's put the x in there. Right, okay. So we're creating a new variable here called x, which is going to start at the cell position x minus 1. Each time it goes round the loop, it's going to add 1 to itself. And it's going to do that while x is less than cell position x minus 1. So looking at number 30 here, we know that that's cell position 30. So the x is going to equal cell position, the x actually is not 30, it's 0, 1, 2, 3. It's going to be 3 because we're talking about the grid, XY grid now. So that number -1 is 29, and that number +1 is that side. So it's going to do a loop around these 3. And we're going to do the same thing in the Y direction. And when we put those together, it will grab all of those cells. So let's copy that and just change these X's in here to Y's. And that will give us a loop that goes around all of our cells, X and Y. Okay, now if we look at our first cell on the board, it's going to give us a negative number. X is going to start at -1. Okay, because the first cell, X, is 0. So 0 minus 1 is -1. That's outside our range. So we're going to say in here, if X is greater than 0, okay, so if we're in range, and X is less than the grid size, okay, because on the other end, 8, we can't have an X position of 9. There's no such thing as an X position of 9. And Y is greater than or equal to 0, and Y is less than grid size. Okay, so if we're in that bounds, then the final index is going to equal the X position plus the Y multiplied by the grid size. Okay, so we're converting it here from our grid into the index. So if we take cell 10, for example, the X position is going to be 1 and the Y position is going to be 1. So Y times the grid size, 1 times 9 is 9, plus the 1 for the X is 10, and so on. So that gives us, that converts our grid position to our grid index. And now we want to add that to our neighbours list, but we don't want to add ourselves. So what we can say is if the index that we've just calculated does not equal the index of the for loop we're currently in, i.e. if it's not ourselves, then neighbours add the index. Then once we're out of that for loop, we can set the board cell I to equal the cell copy with neighbours equaling the new neighbours, and that should generate all our neighbours for us for each of our cells. How can we test that? Well, what we can do is we can pick one here. So let's pick, we're going to say if I equals 12, yep, so if I equals 12, print neighbours. That should work as a test. Let's come to our debug console and refresh. And so here we go. For number 12, we have neighbours of 2, 11, 20, 3, 21, 4, 13 and 22. So that's working. Let's change I to 2 and refresh. And we should have neighbours of 1, 10, 11, 3 and 12. And just to be sure, let's change I to 77 and test down there. And that gives us neighbours of 67, 76, 68, 69 and 78. Okay, so we know, we can delete that now, we know that our neighbours are being generated correctly. So again, I'm going to take all of that and I'm going to extract that to its own method, which I'm going to call generate neighbours. Okay, so we generate the board, we then generate the bombs, we then generate the neighbours, and then we emit the board as though we're playing. Okay, The next thing we want to do is actually calculate the number of bombs next to our grid. So we're going to have to do the same sort of thing. We're going to have to do a for loop. So I'm going to take that for that we've just done and paste it in, because it's the same loop. Essentially, we have to go through each and every one of our cells, and we're going to have a count of the number of bombs that are next to that cell, and we're going to start off with 0. Then we're going to say for int index in board I neighbors. Okay, so for every neighbor within that cell as an index, we're going to do something. And what we're going to do is we're going to say if board at the cell index is a bomb, then we're going to increment count by 1. And then we're going to set the board, the cell, to equal itself, copy with number of close bombs count. Okay, and that should set up that correctly. Let's save that and restart. And now you can see that the numbers reflect the number of bombs that are close to it. Now it doesn't really matter about the ones that are in red, that are bombs. We can ignore those. And that's not working, as you can see. Hang on. I think what I've done, yeah, in this row here, that should be greater than or equals to 0. Let's restart that. And what we should see now, yeah, that looks better. What we should see now is that we have the number of bombs around each of the cells. Let's do that a couple of times just to have a look and make sure things are looking all right. So we've got 3 there. We can see we've got 3 bombs. Got 2 there. Got 2 bombs. And I think that looks okay. Okay, so now each cell knows the number of bombs it's got next to it. So now what we can do is that, well, that's our board set up. We just need to deal with the clicking. Okay, so let's do the same with this. Let's extract that into its own method, and we'll call that count bombs close by, something like that. Okay, quick save, one last refresh just to make sure that's all working, and we'll carry on. Okay, so clicking is going to be an event. So let's come to our events and create a new event called cell tapped. Okay, that's going to extend a game board event. And we're going to need the cell that is being tapped. So final game cell, and a constructor for that. Yeah, so const cell tapped this cell. Okay, so we have that. So let's come back to our game board, and where we have our container, which is our game board, we're going to wrap that with a gesture detector. And we're going to say on tap context.read the game board block add an event, and the event is going to be cell tapped, and we're going to pass in the cell. Let's refresh that and come to our game board block, where we're going to have a new event listener here, which is going to be the cell tapped, and we're going to call the method cell tapped, which we need to create. Okay, so we have this cell tapped. Let's verify that it's working just by printing the event cell position to string. Save that, and so if we tap the first one, it should be 0, 0, and we have an error. I thought I had refreshed it. Let's try that again. Yeah, can't have refreshed it. 0, 0, this should be 1, 0, and this should be 0, 1, and this should be 8, 8. Okay, so we know now that we're getting the tap, and we know that we're getting the correct cell that's being tapped. Okay, what do we want to do? Well, let's get the cell out of the event, because we're going to need to use that a few times. So we're going to say final game cell equals event dot cell, and then we're going to need to know a number of things. First of all, if cell is a bomb, well, explode and game over. Okay, so that's that. If cell number of close bombs is greater than 0, we're going to want to basically show the number or clear that cell. So handle this, and if the cell number of close bombs is 0, we want to clear this and neighbors. Yeah, that's what we want to do. Now, in order to do all of that, we're going to need a bit more data. We're going to need to know whether the cell has been cleared or not. So I'm going to create a new state for that, I think. And I'm going to do that with an enum called cell state. And I'm going to have, for now, unknown and cleared. Might have more later. So I need to keep that. The cell needs to know what state it is. So final cell state state. In our constructor, we're going to say this state equals cell state unknown. And let's just regenerate our copy with to have our cell state in there. Okay, so let's come back to our block and let's deal with just the individual one if it's a number. And so what we're going to want to do here is we're going to handle this by saying the well, we're going to need to find the index of that board. So let's of that cell, sorry. So final index equals board, which we need to get from our hang on a sec, we're in a different state here. We haven't got a board yet. Let's get the board. So the final board is going to be the state as game playing, because we know we're playing if we're here, which will give us the board. and then the final index is going to equal the board index of that particular cell. Right. So here we can then say that the board cell at the index is going to equal the cell copy with state, cell state cleared. And then at the end of all of these ifs, if we get down to here, we're going to omit the board state, or the state, yeah, the whole, we're going to omit the whole state actually. So we're going to omit the state as game board playing dot copy with, which we haven't put in yet. So we need to come to our game board playing, and we're going to need to, yeah, we're going to add a copy in here, copy with, because we're going to be putting more data in here afterwards. If it was just the board, we could overwrite it, but I'm going to put some more stuff in here in the very close future. So we're going to copy with the new board. Right, with that done, we can come to our main, and we've got, if the cell is a bomb, we're going to do red. So let's put these on different lines, otherwise we're going to do grey. But we're going to say here, if cell state equals, it's not an if, sorry, cell state equals cell state unknown, we're going to have the grey colour, otherwise we're going to have also a grey colour but a lighter grey. So let's change that to 300. Okay, we need to restart our app there. So now if I click on one of the numbers that isn't a bomb, it should highlight to say that we've cleared it. And later on, because these numbers won't actually appear at this stage, once the cell is cleared, we will also see the number. However, if I click on a bomb, nothing should happen. And if I click on a 0, nothing should happen. That's correct. But any of these numbers should essentially show us the number. Okay, I'm going to make that grey a little bit darker as well. Let's change that to 400. Yeah, 350. Okay, that'll do. Okay, so with that, we need to deal with clicking on the noughts, because that's possibly the trickier bit to do. Let's come back to our block. What are we going to do if we hit a 0? Well, we're going to have to get all the neighbours. So let's say for integer n for neighbours, in board index neighbours. I'm just thinking about this. Yeah, so this is going to give us all of those. What we can say is if the board or the cell state equals cell state unknown, because we only want to highlight it if it's currently unknown, then we want to set the cell at that position to equal itself copy with state cell state cleared. Okay. Then we want to check whether it, the neighbour, has a 0. And if it has, we want to do all of that again. So I'm going to take this for loop. Yeah, I'm going to take this for loop and I'm going to extract this to a method called clear cell and neighbours. Okay, so if cell is 0, then clear cell and neighbours. So it's going to do what we've just done, and then once it's cleared itself, it's going to look at the neighbour, and if its number of close bombs is also 0, then we're going to clear cell and neighbours for the board, but we'll use the neighbour, the current neighbour, as the index. I think that'll work. There's only one way to find out. Let's hit the refresh button. So if I hit a number, it should just highlight itself. And if I hit a naught, excellent, it highlights itself all the way up to the number, but doesn't go beyond. That's exactly what we want to see. So if you imagine, all the red ones and all the dark grey ones don't have number on it. So now we can see that by hitting the one down here, it's highlighted all of this, and we can see these ones, and we can work out where the bombs are. Right, how do we now deal with working out where the bombs are? Well, to do that, we're going to need to put a flag on the cell. And to do that, we're going to have to deal with a long press, because on an app there is no right click. Okay, so let's come to our board event, and we're going to copy the cell tap, and we'll change that to long press. Okay, there. So coming over to our main, where we've got our on tap, we're going to copy that, but this is going to be on long press, and we're going to do cell long pressed. Okay, let's come back to our block and handle that event. So on cell long press, cell long press, and create that method. Okay, what are we going to do here? Well, we need to set the cell to be a flag or not a flag. So we need to save that state. So let's come back to our game cell and set in here final bool is flag. So when it sets up, this is flag is going to be false, and we'll just add that to our copy with. Okay, so here within our block we need to get a few things out like we've just done before. So let's get the game state as the current state, but I can't call it state because state already exists. So final game state equals state as game board playing. The cell, then, the game cell, is going to be the event cell just as above, and the final board is going to be the game state board, and the final index of the currently clicked item is going to be board index of the cell that was clicked. Okay, so the first thing we want to do is toggle whether it's a flag or not. So the board at the index is going to equal the cell copy with, and the is flag is going to be the opposite of whether the cell currently has a flag or not. So if the cell does have a flag, it's going to not have a flag, and vice versa. That's it. We're going to have to do some more in here because it's actually within here we're going to work out whether we've won the game or not. But for now, that should work. So let's come back to our main, and here where we've got this child, let's put some commas in here, let's spread this out a bit. I think what we're going to need to do is extract this to a widget because we're not always going to want to have the text there. So I'm going to extract that to a method, and we'll just call that cell content. Okay, it's not always going to turn that into a block body. It's not always going to turn text. It might return a widget. So let's say this. If cell is flag, then we're going to return, and I'm hoping here we've got an icons, please have a flag icon. Oh, we do have a flag icon. That's lucky. I don't know what that looks like, but that's what we're going to do. Otherwise, we're going to return the number for now. So if we save that and refresh, if we long press on something, you get an error. Invalid value, not in range. Okay. Let's go back to our block index. I wonder what index it's getting. Let's print that index and see what we're getting when we long press something. Well, you know, that has just shown up. Okay, now I can see what's happening. It's when it unpresses because I'm not emitting the new state. So let's emit the game state, copy with the board, the new board, because otherwise it won't do that. Okay, so let's try that again. There we go. There's a flag. There's a flag. There's a flag. And if I long press on an existing one, it should get rid of it. Okay, fine. So there's our flags going in. And you can put as many flags as you want. But you win the game if you put the correct number of flags on the bombs. So the game is won if there are 10 flags and those 10 flags are only on the bombs. So how do we work that one out? Okay. Well, we need to work out how many flags are on the board in total. So let's get that count, and we can say int number of flags equals the board where the element, let's do that, let's put in too many brackets for us, element is flag. and then we can get that will return all the objects, and we can get the length of that, which will be the number of flags. Okay, and I want to store the number of flags in our game state. So let's come to our game state here, where we have a board, and we'll have a final flags, which is going to be an integer. And so when it's set up, this flags is going to equal 0. And again, we'll just need to update our copy with to include that. So we're going to omit the game state. I'm also going to omit the number of flags as number of flags. Okay. So that tells us how many flags there are, but it doesn't tell us how many are on the correct spot. So the win state is going to be this. It's going to be if the number of flags equals the number of bombs. However, it needs to be more than just that. So we need to say and if, okay, the number of flags on the correct square. And we can do that in a similar way that we've just done. We can say board where element is flag and element is bomb dot length. So that's going to get the number of elements where we've got a flag and a bomb. And if that also equals the number of bombs, then we're in a win condition. Okay, so if we have 10 flags, because we have 10 bombs, and we have 10 squares where the bombs are on there, so get us all the elements, all the cells which are both a flag and a bomb, and if that equals 10, then we're winning. Okay, so how do we win? Well, I think we want a couple more states. I'm going to put in here final brawl game over and final brawl game 1. So this dot game over equals false to begin with. This dot game 1 also equals false to begin with. And let's regenerate our copy with to have those in there. So if that is the case, then we're going to omit the game state, but we're also going to say game over is true, and we're also going to say game 1 is true. Else, we're just going to continue on our way. Right, let's come back to our board and to our main, and let's deal with some of this state, whether we're winning or losing. So to do that, I'm going to wrap the grid view within a column. And that will probably break. Yeah, it will. So we need to put a size around there. So I'm going to wrap that with another widget called aspect ratio. And I'm going to set the aspect ratio to 1 because it's always a square. And that should bring our board back. Fab. After our aspect ratio, then, I'm going to say if state game over. So if state is game over, then I'm going to return a const text game over. And also yeah, let's do an elevated button as well, which is going to be a text play again. And it's going to have an on pressed, and the on pressed is going to be context read our game board block, and we're going to add an event of load board, so that will load us a new board. Okay, we're going to need a refresh there because we've changed our states. So now we can test that. So if I put a flag on all of our bombs, we should end up, hopefully, with a win state. In fact, I'm going to put a flag not on a bomb because that shouldn't win. But as soon as I take the flag off there, we've got game over. I think we want a message as well saying that we've won. So within here, I'm also going to put in if state game 1, then we'll add into our column a text you won. Okay. So there we are, game over, you won. Play again should generate us a new board. Fabulous. Now we just need to deal with clicking on a bomb because that should explode. So let's come to our game board event. Sorry, our block. And if cell is bomb, well, in that case, it's over. So in that case, we're going to return an emit of state. Let's have a think. State as game board state. Game board playing, sorry. Copy with, and here, well, the board's going to be emitted again. Doesn't really matter, we've not changed the board, have we? Not changed the board, so take that off. Game over true. Game over true. Okay, and just to get rid of that error message, we're just going to change this to an async function. Okay, so refresh our board. If I hit a bomb, game over. Right. So I think that is most of the logic done. We just need to change our board now to actually work because we don't want the numbers showing all the time. So let's come back to our main.dart and come down to our cell content. So here we need to return something else. Let's think about this. If we return here if the number of, so we want to know if the cell number of bombs close by is greater than naught and the cell is not a bomb. In that case, we also want to check whether the cell is in an unknown state. So cell state equals cell state unknown. if that's the case, we're going to return null, although it will complain about that for a second. Otherwise, we're going to return text cell number of close bombs to string. So, oh no, we need to return a null here. Okay, now this is going to complain because it can't return a null, but I'm going to set it so it can return a null. That's better, because where that's called, a child can be null, and that's fine. That can be dealt with. It accepts that. I think that's good. Let's save that. So now, if we play again, and we click on something, so obviously there's no bombs near there, so that should clear a whole area for us, which it does. This one has a number next to it, so it should just show us a number, which it does. Yeah, I think that's working. And then if we click on a bomb, we lose. Okay, so the final thing we want to do is make sure, at the moment, we're always showing red for a bomb. And we don't want to do that. We only want to show a bomb if the state is in game over. Refresh. Okay, so now we have no idea where the bombs are. And there's one near there. Okay. And we can play away. So I'm guessing that's a bomb. If I click that, no, it's not. Well, there must be a bomb there. Okay, that's fine. So that works. The bombs all show up as soon as we hit one. So that's clearly not a bomb. Sorry, it is a bomb. That's not. There's two bombs next to that. So that one has to be a bomb, which means that one isn't. Which means that has to be. Which means that one isn't. Which means that one isn't. Now, this is tricky. This is where things get tricky. There are two bombs next to these, so these have got to be bombs, surely. That can't be a bomb. That's got four bombs next to it. Oh, that's not helpful. That one can't be a bomb. That one has to be a bomb in that case. And so does that. That's got three bombs around it. That's got one bomb around it. So that must be the bomb. Oh no. That must be the bomb. That must be the bomb. Oh, have I gotten this wrong? Oh no, that can't be the bomb, because that would be two. So that would be the bomb. There we go. Game over, and we won. I never said I was good at the game. I was just saying we're trying to code it. Right. So that is that. There's one more thing to do, and that is the actual game has a counter at the bottom when you're playing it to show you how many bombs there are and how many flags you've put down. So let's put that in. I think we've got all the data we need to do that. So I need to find our game. So if the game is over, else if the game, oops, wrong way around, else if the game is not over, so if we're playing, then we're going to want text here, and the text is going to be the number of bombs, but we're not storing that in the state. Okay, So we do need to store that in the state, so we've got access to it. So in our game playing state, final int bombs, and we'll default that to this bombs equals 0, and we will update our copy with, and then when we create our board in the first instance where we load the board, we will set here the number of bombs to be the number of bombs. Okay, so having saved that, the text is going to be state bombs minus state flags, and we'll need to put that in because that's a calculation, and convert that to a string. So let's refresh that, and we should find that we have 10 flags, and that's fine. That should go down, and that should actually go to a negative number if you put too many down to indicate, yeah, and that's fine. That's how the game actually worked. Okay, so we've got a bug here. I've just discovered a bug, is if the board is already cleared, we shouldn't be able to put a flag on it. Let's come back and fix that then, the game board. So that'll be on our long pressed. So yeah, we'll say here, we'll get our cell, and we'll basically say here, if cell state equals cell state cleared, return. And again, we'll just async that. Okay, so if we're trying to put a flag on a cell that's already been cleared, then we're going to refuse that to work. Let's try that. Let's see if we can randomly get a cleared part. So now, yeah, we can't put a flag on a cleared cell, but we should be able to put it on an uncleared cell. Okay. And then I've just thought of another little problem, and that is if we'd put a group of flags here, for example, and then pushed this button, this area would have still cleared, but the ones with the flag on would also have cleared, and it shouldn't have. So to fix that, there's a few ways of doing it, but yeah, what I'm going to do is, after we've cleared our cells and neighbors here, I'm just going to go through the board and make sure that anything with a flag on it is uncleared. I think that's the quickest way of dealing with that. So yeah, I'm going to do that. So let's copy this for loop here. So after we've cleared our neighbors and cells, we're going to whiz through all of them, and we're going to say if the cell at index I is a flag, then cell at index I is going to equal itself copy with state cell state unknown. Yeah, and that will ensure that we can do that. A quick way to test that would be to come and just comment out that bit there so we can see where our bombs are again. So if I put a group of flags around here, and then click one of these two, it should clear all that area, yeah, but doesn't clear the ones with the flag on it. However, if we then later on cleared all those flags and clicked on one of those, it should clear them. Okay, that's fine. I can put that back. We may also want to do some checking on the cell tapped. So let's go back to our game block, and on cell tapped, let's have a think. If we don't want to be able to tap on a cell that is a flag or a cell that is already cleared. So, okay, if cell state equals cell state cleared, or cell is a flag, or, thinking about it, yeah, let's have this, or state as game playing dot game over. So if the game over, if any of those are true, then we're going to return. Yep, so if the cell has already been cleared, it would do nothing. If the cell is a flag, we do nothing. Or if the cell, if the game's over, yeah, we do nothing. Let's just check that. So if I put a flag on there and now click it, it does nothing. If we take the flag off and we click it, it does something. So if we put a flag on there, I shouldn't be able to accidentally push it, which is fine. We take the flag off, boom. And that's it. Anything else is just tidying up and making things look pretty, which I'm not really going to do much of. I am going to take this text with the flag and I'm going to wrap it in a row, and I'm just going to put the icons flag just to give people some idea of what that is. And we'll main axis alignment center that, so we just know how many what that means. But other than that, that is the very basics of creating Minesweeper in Flutter. I hope you enjoyed. If you have, don't forget to leave a like and subscribe. It does help me out. And we'll see you next time. Until then, folks, take care. Bye now.